So we're going to start off with univariate data. A lot of this is going to feel like revision. A lot of this is going to feel mundane. The reality is it is. A lot of this content is quite mundane, and you're going to be sitting here like, oh, same thing over and over again. Reality is it is. The summary book for this section, the big part of the summary book, not the little part, is going to be really large, and then you can condense it down really well. Because there's a lot of stuff here that's like, I don't really need it in my summary book. I'm going to put it there just because I want to have it there. But I don't really, in my little summary, I don't need it because it's stuff that, you know, I should know pretty well. So, jumping in, we start off with data. So, what is data? So, data is all about facts and statistics that are collected together, you know, in the reference or analysis. And then we have variables. So, what we measure to collect data. So what variables do we look at? What do we do to collect data? And how many variables? So we then look at univariate 1 versus bivariate 2. And this is where things get a little bit more complicated. So as you can see here, we then can discuss, well, if we have univariate and we have bivariate, what if I have, you know, I have two pieces of data, but what if they're both different? Well, then I can say, well, one of them might be categorical, which is names, and then one of them might be numerical, which is, you know, your values and your measurements. So from there, what else can we get? Well, we can get from here different subtypes. So we have categorical, we have numerical. Now, we can break these down further, as I said, into our subtypes. So we'll start with categorical. So categorical is all about categories. Makes sense? It's called categorical. It's got categories. Now, the categories that we're going to look at, are we going to look at things like eye color, football team, etc. Now, what's really cool about those things is you can't really order them. Like, sure, maybe like a football team, you can order it by the ladder, but you can't really order it. There's no way of ordering these things. But there are ways of ordering other categories. So, order is our way of subcategorizing categorical things. So we have nominal, which is, there's no sensible way to sort these categories. So if I'm doing eye color, it doesn't really matter the order of it. I can do brown eyes first, I can do blue eyes first, I can do green eyes first, I can do aqua eyes first, I can do hazel eyes first. It doesn't really matter which order I put these in. So I go, you know, in this case I do hair color. I've got, you know, blonde, brown, red, black, etc. There's no way of ordering that. However, if I do ordinal categorical, this is a little bit different. I can order some categorical pieces of data, such as very satisfied, somewhat satisfied, neutral, somewhat dissatisfied, very dissatisfied. That has a general order to it. Yes, you could start at dissatisfied or satisfied. Doesn't really matter which way you start, but it has a general order to it. Now, numerical data, on the other hand, can be measured. So categorical data cannot be measured. It needs to be sort of counted. It doesn't even need to be counted, it just needs to be obtained. Numerical data, in a sense, is measured or counted. And we think of it in two distinct ways. There is discrete, and then there is our continuous. Now, what is the difference between the two? Well, discrete is more in the sense of something that we count, and therefore it's usually whole numbers. Now, there are exceptions that allow some decimals in there, but it's more about counting. I can't say I have half a dog. If I'm going to count the number of dogs people have, or the number of pets people have, I can't say I have 2.5 pets. That makes no sense. It needs to be 2 or it needs to be 3. There is a distinct number. Now, there are some exceptions to that. Things that are counted in 0.5s, or maybe like a common example in the past has been an ATAR. So ATARs go up by 0.05s. That is a discrete because you can only be on a 0.05. It goes, you know, 0.05, 0.10, 0.15, 0.2. That's how it goes up. Like 99.95, 99.9, 99.85, 99.8. Like, it counts by that. Usually, though, we say it needs to be a whole number. Continuous, on the other hand, is something that's more measured. And it's something that usually they use weight, temperature, height. These things can go to as many decimal places as you want. Depends on how accurate you want to be. So if I weigh, you know, 5 people and I find they're, you know, 80.2, I find one of them's like 100.5. I find someone's like 89.32. I find someone that is like 92.67, or I find someone that's like 50.25. You know, it's a measurement. They're different values. They can be anything. They don't have to fit into, you know, 1, 2, 3. They don't have to fit into that. So that is how we look at it. And this is a great way of sort of summarizing it in your summary book. You have, you know, your categorical, numerical, and then you go, all right, well, is there an order? Is there not an order? Do I count or do I measure? And that is how we look at these things. So another way of thinking about it as well is these questions that I'll pose to you. So my first question is, can it be manipulated? So can I manipulate this piece of data? Does it make sense to find the mean, median, mode, range, etc.? Yes, well then it's numerical. If it's not, then it's, you know, it's categorical. It makes sense to subtract two heights from each other. It makes sense to find the median height, the mean height, etc. It doesn't make sense to find the mean, you know, football team. That doesn't make sense. There's no order to it. There's not even anything else going on with it, so you can't really do that. Can it be counted or measured? Yes, no. Although numbers usually mean that a variable is numerical, it always doesn't. This is a really good point. A really common categorical ordinal, so it can have an order, a categorical ordinal piece of data. It's really common, it comes up a lot. Postcodes. Postcodes are a number, so you would think that's numerical. However, postcodes describe an area. So my postcode describes my area. So, etc. Example, 3000 is Melbourne CBD. 2000 is Sydney CBD. They describe an area. They are not describing a value. Yes, they can be ordered because you can start at 1 and you can go to whatever the largest one is, but they describe an area. And as such, that postcode is describing a categorical piece of information. It's a categorical ordinal piece of information. So this is that example there. Is the number being used as a name? So postcode. Another way of thinking of this is a house number. Another way of thinking of this is like a rating, so 5 stars. A really common one as well is like shoe size. So shoe size, that comes in numbers. Starts at 0, goes up to ginormous sizes. That's just like 20 or something. They are a number, but they are utilized to describe a size. So they're utilized to describe a size, and therefore we would call that ordinal categorical. So here's a really quick question for you. If you're playing along at home, pause your video now just quickly and go through and name each of these. So I'd go through the first one and say, all right, how often do you study? Often, sometimes, rarely. Well, if I said, how much did I study in hours? I think that's sort of like a category. I think that's like a numerical. Could be continuous if they're asking for specifics, but it could also be discrete if they're just asking to the hour. But they're actually asking it in terms of often, sometimes, rarely. Therefore, I'm thinking this is categorical, and that does have an order. So I'm thinking categorical, ordinal, etc. Go to the next one, temperature in degrees Celsius. Well, this is a measurement, so I'm going to say this is numerical, continuous, etc. Move on. I want you to go through and do the rest of them. So pause, 3, 2, 1. And hopefully you've unpaused and you're back. Hopefully you had a go at this one and you got the answers here. So another one here, this is from the 2016 Further Exam 1, so a multiple choice exam. We have the variables of blood pressure and age are which of the following? So what's really cool about this question, or what was not very cool about this question, was only 31% of people got this right. So this was more of a difficult question. So have a quick think. 3, 2, 1. All right. So this question here was a little bit more difficult in terms of that we find that there are 2 variables, and one of them is very much sort of a categorical ordinal, because as you can see here, we've been told that low, normal, high. It's clearly categorical. It's clearly describing what's going on, and a low, medium, high. Now, then we have under 50 and over 50. Now, what was really interesting about this question is a fair proportion of people thought this might have been a numerical piece of data. So they thought this could have been a continuous piece of data. And so a lot of people went for E. And then a lot of people also went for D, because we had an ordinal. So we clearly had an ordinal, so that's covered with our low, normal, high. But a lot of people said, oh, well, under and over 50, it's just 2 categories, so we're just going to say this is nominal. Well, it actually wasn't. It's also ordinal, because you can order that. You can say, well, if you're under 50, that's at the start. If you're over 50, that's at the end. You can order that. So the answer to this was actually B. So both ordinal variables, and only 31% of people got this right. That's 31% of the cohort got this question right, which was question 2 on the exam. So usually you will find, it's something I didn't talk about in the tips, with the exams, the easier questions are at the start, the harder questions are at the end of the groupings. So you'll have, your 16 data questions and you have 8 of all the others. And usually the first 2 questions will be easier, and usually the last 2 or 3 questions will be a lot harder. The middle questions usually vary, but it just happens to be that the first 2 questions are a little bit more straightforward than the last 2 or 3 questions. It always happens to be that way. This is essentially one of their more straightforward questions on the exam, and 31% of people got this right. So if you're able to get your head around this concept and understand it, you're already going to push yourself ahead of it at a minimum 50% of the cohort, and that's what you really want to be doing. So